Okay, I would like to introduce today's presenter. Ami Vora is a product manager with the Windows Communication Foundation at Microsoft Corporation. And again, the title of today's MSDN webcast is Programming the Windows Communication Foundation. Ami, you now have the floor.
Thanks, Jeff. Good morning, everyone. Thanks for joining me. As Jeff said, my name is Ami Vora. I'm the product manager for this thing that we all still know and love as Indigo, but have to call the Windows Communication Foundation or risk getting in trouble with legal. You can see my email address and blog on the screen. Feel free to drop me any questions or comments after the show. What we're talking about in this talk is how we actually use the Windows Communication Foundation. WCF, if you know anything about it, is a huge and very functional distributed systems platform. It is the Microsoft way to build distributed systems or web services going forward. We, the WCF team, own all of today's distributed systems technologies like ASMX or ASP.NET Web Services, like Web Services Enhancements, COM+ Enterprise Services, System.Messaging or MSMQ, and .NET Remoting. And what WCF is a superset of all of that functionality under a single unified programming model. So this is a big task. The thing that I think is most important about WCF is that what you need to know in order to build a powerful application is just a few fundamental concepts. And that's what we're going over today. This talk builds on the previous talk in the series, which is the introduction to WCF, or the overview to WCF. And you can find that linked off of our windowscommunication.net website. So let's get started. We're going to start by going over the core concepts for WCF, everything you need to know in order to build and run basic applications. Then we'll drill into a few of the most important of those concepts, namely the contracts, the bindings, and behaviors. As Jeff said, we will be taking questions at the end of the session, but if you've got any questions in the interim that can help me focus what I'm talking about, feel free to pass them along. Let's start with the core concepts. The basic model of communication here is through services. I won't be talking about network topology, whether it's better to have a centralized versus a decentralized network system. That's something that depends on you and your scenarios. What I will be talking about is how services communicate, what communication looks like between a client and a service. And once you understand that, you can generalize what's right for your situation. So we begin with two services, a caller or a client, and the service that's just serving up information. The service is just sitting there waiting for someone to contact it. So the caller initiates that communication by sending a message to the service. Now this message could be anything. It could be, if the service is a voting application, it could be increment the number associated with this candidate by 1. I'm always tempted to make a joke about Florida and Ohio, but I will refrain in this case. So it could be, the message could be something else. It could be, add this item to my shopping cart. It could be something that doesn't have UI. This is the status on the factory floor. Now the service can also, of course, send a message back. This doesn't have to be one-way communication. That communication happens between endpoints on the caller and the service. An endpoint is very similar to, say, an interface on an object. You can walk up to an object and pick an interface with which to communicate with it, and you don't need to know anything about the implementation details of that object. The endpoint on the service is the same way. The endpoint contains all the information you'll need to know in order to communicate with the service. Now, WCF is all about loosely coupled services. So that means we don't want the caller to be dependent on any of the implementation details of the service. So what the caller does is manufacture a proxy endpoint on its side. So it takes a look at what the service endpoint looks like, manufactures a proxy on its side, and then makes what look like local calls to its proxy endpoint. That proxy endpoint on the caller side takes care of all of the communication with the endpoint on the service side. So communication is only endpoint to endpoint. That means you can change implementation details on either side, and no other services will be dependent on it. Now, of course, you can have multiple multiple endpoints on any of these services. In fact, that's probably the best practice to do different sorts of communication. For instance, on a service, you could have one endpoint to do interoperable, cross-platform, through the corporate firewall communication that uses, say, HTTP and a text XML encoding. You could have another endpoint for efficient, non-interoperable, inside the firewall communication that uses, say, TCP and binary encoding. So what's actually in these endpoints? We call these the ABCs of Indigo, and I would love to say that we did it that way on purpose, but that would be a lie. But now that we've done it, we're going to milk it for all we can. So inside every endpoint is an A, a B, and a C, an address, a binding, and a contract. The address is the where of this service. Where is the service actually living? That's something like HTTP, whack, localhost, my service. The binding is the how of the service, how it actually communicates. So this includes things like, what sort of security are we using? Are we using reliable messaging? What sort of transport are we using? These are often things that are separate from what the service actually does. You know, these are things that an IT pro or a system administrator should be worrying about. What developers most of the time are interested in is the contract, what the service actually does. So this corresponds to what methods are exposed on the service, what operations can you call. So the endpoint includes this address, the binding, and the contract, which is, of course, everything you need in order to communicate with that service. But how do you find out what's in these endpoints? The answer to that, as is the answer to many things, is metadata. Just as today you can go out to a COM component and query interface, you can figure out what interfaces you can choose. You can go out to a service and download its metadata. And that metadata will include the address, the binding, and the contract, the information you'll need in order to communicate with any endpoint on that service. We'll see examples of all of this when we go through our demo. There's one more piece, and that's behaviors. Behaviors are system semantics. They're things like what the instancing model is for a service. You know, is it a per call instancing model, or do we have a single service to respond to any call sent to it? Or what's the concurrency model? Is it thread safe? So behaviors are system semantics that are usually internal to that service that determine how that service behaves. The final piece is what happens at runtime. You can host one of these services anywhere. I mean, a WCF service is just managed code. So that means you can host it inside a WinForm, or you can deploy it into IIS and it'll open for you. You can also host it inside a console just by using this class we call service host. And when you do that, the service host class will spin up all of the infrastructure that you need to host a service for you. So it will automatically generate that metadata we were talking about. Then the caller goes out and downloads that metadata, uses the service metadata to generate a proxy on the caller's side, and then can use that endpoint on the caller side, that proxy endpoint, to communicate with the endpoint on the service side. All right, that's a lot of concepts. So let's go ahead and see an example. So I just fired up Visual Studio 2005, which is Whidbey, and we're going to start from scratch. We're just going to open a new project. And we're going to use that service host class, so we're just opening a console application. This is a simple Hello World application, but I like to make it a little more interesting by including some fortune cookie generation, if you will. So let's call this fortune cookie. And this is going to be our service. Let's ignore the program class for now and go straight to writing our service. The first thing we need to do is add the reference to system.serviceModel. this is the Indigo namespace. Sorry, the WCF namespace. See, now I'm going to get dinged by legal because of that. Service model. And that really includes most of the WCF functionality. So what we're going to start with is simply creating a class that we're going to use as our web service. So let's call it Fortune Cookie Service. And all we need in this class is that one method that retrieves a fortune. So I've written up a simple fortune cookie application. Let's just pull that in, and we'll take a look at that. So this is just a fortune generator. And the way I arrived at this was by eating a lot of fortune cookies in one evening. And all it does is return a somewhat random choice from one of these answers I've provided it. So if we go back, what we need to do here, of course, is change the namespace to just Fortune Cookie, which is our namespace here. Okay, so we've changed it to Fortune Cookie. That puts us in the same namespace, which means now we can call it. So let's do, what we need is to return a string for a method called getFortune. And we can do fortunegenerator.getFortune. And in fact, we can just go ahead and return that. Okay, now what we need to do is specify that this class will be exposed on the wire as a web service. It will be accessible to any clients that are calling it. And the way we do that with WCF is by decorating it with an attribute called service contract. Service contract says, expose this class on the wire as a service for any callers. Now WCF uses an opt-in model, and that means that even though the class is automatically exposed as a web service, any methods inside that class need to be specifically exposed as methods on that service. And we do that by using a similar attribute called operation contract. Operation contract says, expose this method as a part of the service. And that's our web service. That's all we need to do. Now we need to spin up the actual infrastructure, the hosting and metadata generation of the service. We're going to use that service host class. So let's say service host sh equals a new service host. And before we do that, let's actually specify an address. So URI adder equals new URI. And we'll just run this at HTTP, localhost. And we'll run it at Fortune. Okay, so we're going to spin up a service host, and the instance of the service, the type here, is going to be type of Fortune Cookie service. And the base address will just be adder, which we've just defined. So now we can open and close. And we'll just keep it open by doing a console read key. And that just says stay open until, keep this console window open until I hit a key. And let's also write when we're ready. So write line, service at your service. Okay. Now the key thing here is to create that endpoint, the address, binding, and contract, so people will actually be able to communicate with this service. So we can just add a service endpoint, and we need a type, which is the type of Fortune Cookie service. We need a binding. Remember, that's the how of the service. That's how it communicates. So we're just going to use a new basic HTTP binding. And we need an address, and that'll just be adder again. All right. Let's just see if this works. So let's start rebuilt, and the service is at our service. Okay, let's go out and actually create a client, because right now the service is just generating information. In fact, if you're used to doing as a MEX, you can see what's going on with the browser. Here, let's just start up and see what happens when we navigate here. And we've created the service. It's up and running. But to actually see what's happening, we need to create a client and communicate with the service. And this tells us how. It says we need to run this line. So let's go ahead and start creating a client. Now usually this will be done on another machine, but I only have one at my disposal right now. So we'll pretend. And once again, we're going to use a console application. Let's call it Fortune Cookie Client. As always, we need to add that reference to system.serviceModel. Okay, now let's go back to our service and see what it tells us. It says we can do this by using the Service Util tool. Remember, our service has all of this automatically generated metadata. And what the client needs to do is download that metadata and bring it into the client so the client can create a proxy endpoint. So let's try this. We'll just copy this line. Oops. And we'll run our SDK window. This is a command shell that ships inside the Windows SDK. So here we'll just call the line that we were instructed to call. What happens here is that Service Util goes out to this endpoint, to this WSDL, which is automatically generated by service host on the service end, and it will create a couple of files we'll use to create the proxy on the client side. So let's pull those into our client. We've got this thing called Fortune Cookie Service.cs and output, and we'll take a look at what those are. Let's look at the Fortune Cookie service. What this does is implement, as some partial classes, the Fortune Cookie Service proxy. This is what we'll use on the client side to communicate with the endpoint on the service side. We can even see that any methods are implemented here. Any methods that are exposed on the service are implemented on the proxy. And then the proxy takes care of the actual communication with the service. So on the client side, we're going to make what looks like a local call to get Fortune, and that's going to communicate with the service to replicate that action on the service side. What was that other file? We have something called output.config. I'm just going to rename that to app.config because that's what the system will look for. And this is an XML file that tells us about the binding. It tells us how to communicate with the service. So here we can just see that it sets several values, like what the maximum message size is, all of that. So now let's just call that proxy. So for Fortune Cookie Service Proxy, P equals new, Fortune Cookie Service Proxy. And then we can just call get Fortune on P. And in fact, we can just print that to the screen. All right, let's try this out. Our service is still running. So let's just try running the client. And I will travel widely for business and for pleasure. Isn't that a great Fortune? I'm so glad I wrote these. So that's how easy it is to create a simple service and client. It took us very few lines of code. It took us, about 10 minutes. Think about what you can do with an entire development team. So let's shut down the service and client and head back to those slides. All right, now let's drill into some of those fundamental concepts. We saw how we expose the service and the methods on the service using contracts. Let's talk a little bit more about those. So we saw the service contract, which describes what a service can do. There are also a couple of other contract types we'll talk about. One of them is a data contract that describes how to serialize a data structure across the wire. And another is the message contract, which tells you what goes where inside a message. And we'll talk about why that's important. We see here what a service contract looks like. We're saying expose iCalculator on the wire as a service, just as we saw in the demo. And then expose this method, solve problem, as an operation on that service. To recap, once again, WCF is an opt-in model. So that means that just putting service contract on iCalculator isn't enough. We've got to specifically opt in anything we want to be exposed on that service. Now, of course, we had to give you lots of options. So all of these attributes will also take parameters. For instance, one of them is the is one-way attribute. And that determines the messaging pattern. So without is one way equals true, the store problem operation will default to request reply. I'll send a message and I'll wait for you to send a response back. If we put is one way equals true, we switch to using a kind of message-oriented pattern, which is fire and forget, the MSMQ pattern. It used to be that making this sort of change would require a whole lot more work, maybe even a change of tool sets. But with WCF, you can get simplex messaging by just adding a parameter to the method you want to use it on. That's pretty powerful. We also do full duplex messaging. Here what we're saying, what we've got in the top here, the iCalculator problems, is the service implementation. So we're saying inside that service contract attribute, prepare to receive messages asynchronously from iCalculator results on the client side. So inside the service, we have to generate a dummy, a proxy stub for iCalculator results that matches the signature on the client side. And we do that right under the service side declaration. So we support here asynchronous messaging. The last service contract I want to talk about is fault. Not, of course, that anyone would ever make mistakes, but there are two kinds of faults, two kinds of errors in a service, and I think it's important to distinguish between them. There are the errors that you don't want to pass back to the client and the errors that you do. So for instance, if I'm buying a book from an online bookseller and something bad happens on the service side and the service accepts, dumps core, whatever, I don't want it to send me back, say, a stack trace. And that's for a couple of reasons. First of all, I shouldn't know anything about its implementation details. To keep this whole thing loosely coupled and autonomous, to keep my side autonomous from the bookseller side, I shouldn't know anything about what's happening behind that service. For another thing, I can't actually do anything about that error. I don't control the service. So that's an exception. That's something that the service should take care of itself and not pass back across the wire. The other kind of error is a fault. Not something that should be passed back across the wire. For instance, if that online bookseller is failing because I'm sending it bad information, I'm sending an invalid credit card, then it should send back a response that tells me what I'm doing wrong and informs me of how I should change that. And so the way to set up faults is simple. You just implement a fault contract and then specify what type of fault you're willing to accept. And then inside the catch block, you simply throw that fault with whatever comments you want to be passed back across the wire to the client. So those are service contracts. Let's move on to data contracts. Data contracts specify how to serialize something across the wire. Now we know how to serialize simple types like ints or like strings, but if you want to serialize a class across the wire, we want some more information. So here we're letting you choose what goes in and what is serialized as a part of the class and what isn't. Once again, the opt-in model. So even though you decorate complex number, the class, with the data contract attribute, you also need to decorate any members of that class that you want to be serialized with the data member attribute. The last kind of contract is the message contract, and that determines what goes where inside a message. By default, WCF messages are sent as SOAP envelopes with a header and a body. And the reason it's important to know what goes where is that the body of a message is reserved for the destination application. So anything in the middle, any intermediaries or load balancers, any routers, can only look at the header. For instance, in this example, if we wanted to do load balancing on this type, and we wanted to send, for instance, all of the addition and subtraction to one cluster and all of the multiplication and division to another, we would want the operation to be visible in the message header, so that any routers or any intermediaries could route the message appropriately based on what operation the message was requesting. So that's contracts. The next fundamental concept is bindings. And these are the how something communicates. I think about bindings as basically a combination of any number of elements that determine communication. So when you discuss a binding, you want to talk about what transport it's talking over, whether that's HTTP or TCP or name pipes. You want to talk about what encoding it's using, whether that's text XML or binary, whether it's using security, and if so, what kind, whether it's using reliability, if so, what kind, all sorts of stuff. These are often things that are controlled by an admin or an IT pro. So when we talk about a binding, it's just a bunch of these elements. For instance, here's one of our standard bindings called Basic HTTP Binding. This is the one that we just used in that demo. And all that includes is the HTTP transport and the text encoding transport, and the text encoder. Now if we wanted to add security and reliable messaging, we could use the WS HTTP binding. And that uses default WS star security, WS star reliability. Or if we wanted to do more optimized intercorp communication, we could use our net TCP binding, which uses the TCP transport and the binary protocol, so it's a little bit faster, that keeps all the WS star security and reliability. Another thing to note is that custom is an option for each of these elements. All of these are extensibility points. So you could roll your own transport and simply invoke it in the binding, and then you'd be using it. You could roll your own encoder or your security system. We ship a lot of standard bindings out of the box. Here's the current list. The idea is that these will solve 90% of the situations you're looking at. Of course, they span a variety of things. Some of them are interoperable, some of them have default security, some of them allow you to use reliable sessions. Bindings will also help you interop with today's technologies. So WCF is wire interoperable with WYSI-3 and ASIMX using the WS HTTP binding or the basic HTTP binding. We've also got a binding that creates a moniker on the CommPlus Enterprise Services apps so that WCF can communicate with them over the WS star protocols. And if you're using MSMQ or system.messaging, both of them speak MSMQ across the wire. So in your WCF application, you can use the MSMQ binding to communicate with those apps. Now, I've been pointing out that often binding is something that IT pros will want to fiddle with, not necessarily developers. And so what WCF gives you is the ability to split what developers are concerned about and what IT pros are concerned about into different files or different systems. The way we do that is by using these XML configuration files. These are files that are read at runtime and that often specify the binding that a service uses. When we wrote that fortune cookie service, we had to specify the address, the binding, and the contract inside the service itself. But we could also have used an XML configuration file that specifies the exact same thing, the exact same endpoint. And we'll go back and do that in just a second. Of course, bindings are configurable. So you can start with one of our standard bindings and then tweak some values. So for instance here, we're using the basic HTTP binding, the same one we used in our demo. And then we're deciding to tweak some things. We want to use a specific hostname comparison mode. We want to set a specific maximum message size and use a specific text encoding. So we simply say that we're using a particular binding and then specify which binding configuration on that basic HTTP binding we want to use. Inside that binding configuration, we then specify whatever values there are we want to tweak. And of course, you can create entirely custom bindings. So here, you simply note which particular elements you want to choose. Here we're going to create a custom binding, and we specify we're going to use a reliable session, we're going to use HTTPS, we're going to use a text encoding. You can also, of course, invoke any of your custom transport or any of your custom binding elements right here. So let's go back and see how we can use bindings inside our existing application. So go back to the Fortune Cookie service. And right now we're doing all the endpoint stuff inside code. Let's instead do that inside an app config file. So we'll add a new XML file called app.config.
Hey, Ami?
Yep.
You forgot to share out your desktop.
Oh, I'm so sorry. Thank you for pointing that out, or I would never have remembered.
Sure thing.
Okay. Sorry. So all I did here was comment out my service endpoint that I defined in code, and I created the new XML file just by doing add XML file. So that gave me this app.config file. One of the cool things about using WCF is that you get IntelliSense on XML, which is really amazing to me. So we're specifying, it means I can write XML from scratch, which is usually a terribly masochistic thing to do. So we're going to use system.serviceModel. That's our WCF namespace. We're talking about services. In particular, we're talking about one service that's called Fortune Cookie, which is our namespace, .FortuneCookie service. So our service type is Fortune Cookie, .FortuneCookie service. Let me make sure I got that capitalization right. Okay. And we want to define that endpoint. So remember, in our code, we just said this was the type of the service. We're going to use the basic HTTP binding, and we're going to use this address, localhost/Fortune. So let's do the exact same thing here. The address is localhost/Fortune. The binding is basic HTTP binding. And the contract is Fortune Cookie .FortuneCookie service. Okay, and that's all. So let's see if that actually works. I'm going to save all those changes. We do need to rebuild, because remember we commented something out in our code file. So let's go ahead and rebuild and restart. Now, we should try the client, because we didn't actually change anything on the service side. We just moved a declaration from the service to the client. So the behavior should be exactly the same. And a light heart will carry us through difficult times. So everything looks exactly as we expected it. Let's mess a little bit with the binding on the client side. We use that SVC util tool to go out and download the service metadata and bring it back to the client. So it automatically generated this app.config file. But this file is a little bit ugly. Right now what SVC util does is take a guess at what the service is using and then set a custom binding for it. So it's telling us, I think the service is using basic HTTP binding, but since I don't actually know, I'm just going to set all of these values to be the closest I can think. But we can cheat. We actually know that the service is using basic HTTP binding. So let's just use that to simplify this file. That means we can just get rid of this whole binding configuration. There, isn't that nicer? Once again, we haven't actually changed any functionality here. We've just simplified how the XML looks. So if we just rerun this application, if we rerun the client, we should see exactly the same behavior. Remember, we don't need to rebuild because we've only changed the app.config file, and that's read entirely at runtime. So we can restart, and we once again get another great fortune. Before we leave off with this binding stuff, let's take a look at how to secure this communication using just the binding. let's start by adding some logging functionality. So first let me shut down the service. And I'm going to run a tool that's shipped inside the Windows SDK called Service Config Editor. This will help you write those XML files if you don't, as I do, enjoy writing XML from scratch. Now I've just got to find this file. And this is Fortune Cookie, the service side. So I'm asking it to change what's in the app.config in my Fortune Cookie service. And what I want to do is set up logging, so I can see exactly what messages are passed between the client and the service. So I'm going to create a standard WCF message trace listener, and I'm going to ask it to be put into app_messages. That's where all of these messages will be logged to. And I'm going to ask it to log the entire message that it sees, and log every message that's passed across the wire. Okay, so we'll just run that. I'll save those changes. And now when I go back to the service, whoops, I wonder if I did something wrong. Let me try that again. I'm not quite sure what I did. What I should get, yes, so it just didn't give me the refresh. What happened is that the app.config file had a whole lot of listening information injected into it by that tool. So the Service Config Editor put in all of this diagnostic information that specifies that it's going to log every message sent across the wire between the client and the service to that file I specified, app_messages. So let's save that and restart. Once again, it's a config file, so we don't need to rebuild. The behavior is exactly the same, so we'll shut down the service and the client, and then we'll go look at that file. And we'll do that using the Service Trace Editor, Service Trace Viewer. Once again, I have to navigate to this thing that I put in a terrible place. And so we're looking at that app_messages file. And we can see that we had 2 messages passed across the wire. Eek. Sorry, I'm having a little bit of trouble finding things. We can see that what we sent, the action we sent, was the get fortune operation. And what was passed across the wire was this result: your talents will be rewarded. Now all of these things are in clear text, so anyone who's sniffing this wire can see exactly what we sent back and forth. Let's see how we can secure this by just using the bindings. So we'll go back to our service config file. Right now we're using a basic HTTP binding. And as we remember, that's just the HTTP transport with the text XML encoder. Let's switch to another standard binding. Oh no. Let's switch to another standard binding. I wonder if I just killed something. And use instead the WS-HTTP binding. And that uses the HTTP transport, the text XML encoder, along with WS star security. So we'll save that and see if this still runs. All right. Now let's go back to our client and make that exact change. We need to have the same binding on both sides so that the policies match and everyone knows what to expect. So let's rerun this application. Ignorance never settles the question. I think that one is personally relevant right now. And then let's shut down this service. Now if we go back to that log, we can refresh to see any new messages that were added. And whereas before we only needed 2 messages for this communication, now we've got 8. So let's take a look at what's in these messages. We'll switch to message view so we can just see the SOAP body. And everything in these messages is encrypted. So even when we're actually sending that request and sending back the fortune, the payloads of all of these are ciphered. So if this is sensitive information, now anyone, even if they're sniffing the wire itself, can't actually see what's in the bodies of these messages. We made this change just by 2 code changes on either side of the wire. We didn't need to rebuild anything. These are things that system administrators can change in config files that are then read on runtime. Remember, all we changed was this binding to another standard binding that simply uses security. That's the sort of power we're looking at. So that's binding for you. Let's go back and touch briefly on behaviors. And these are the system semantics of a service. There are a variety of behaviors, some of which developers care about and some of which deployers care about. For instance, developers usually care about concurrency, whether something is thread safe, or what the instancing model looks like, or whether transactions are allowed, what sort of impersonation you're allowed to use to pull client identities into a service to run operations. And of course, deployers care about some things. What sort of throttling is allowed, what the connection pool looks like, how many services you're allowed to run at one time, how you actually expose that metadata, and what you expose. So we'll just briefly look at a couple of examples here. Let's look at instancing. And WCF offers 4 basic instancing models. There's the per call, which means that a new instance is spun up for every call that comes in. And this is good for one-off operations like a calculator. There's the singleton instancing, which uses a single instance to respond to all calls. And that's something like a voting application that needs to maintain state across everything. And then there's session instancing. So there's private session, in which every client gets its own session of the service, its own instance. That's used for something like a shopping cart, where you want only your items inside the shopping cart. And there's a shared session, where one instance is used for multiple different clients. And that's used for something like, let's say, online gaming, where you want to share state across a bunch of your friends. Now in code, we can do this using those attributes that we've been using all the time. This is just a service behavior attribute, in which we use a parameter to specify exactly which behavior we want to set and what we want to set it to. So here we're saying we're going to use a singleton instancing model, in which we use a single instance to respond to every call. Now we can also specify behaviors inside config for our IT pros, for our deployers. For instance, they care about throttling, and so inside our config file we can use the behavior configuration attribute and then tweak whichever configurations we want to use. Here we're specifying that we're going to throttle our service to only allow 10 calls, 10 connections, 10 simultaneous instances of that service. All right, that actually brings us to the close. So what we went over today is the core concepts of WCF, how 2 services communicate and what that looks like at runtime, and also some more details on the bindings, the contracts, and the behaviors you're going to work with. My takeaway here is that you could spend really the rest of your life exploring what WCF can do for you. But what you actually need to know in order to build powerful applications is contained in just a few minutes of the talk. So the fundamental concepts we went over today are enough to get out there and start using WCF to build powerful and functional services. Once again, my contact information is on the screen. I also recommend our new community website, which is called windowscommunication.net. That's a great place to get started if you're looking for more information. I'm going to pass it back to Jeff.
Thank you, Ami. Yeah, I'd like to take a minute here to share some additional resources. Talk quick about questions. We'll begin looking into the questions here in just a moment. Once again, you can ask a question by typing your question into the field next to the Ask button and just click Ask. I will be providing a survey for today's event in just a minute. When you see that, please take a few moments to complete the survey. feedback and comments that you provide ultimately allow us to create better webcasts for you. So your feedback is greatly appreciated. I have a couple of URLs I'd like to pass along. If you're looking for upcoming or previously live webcasts, there's the URL for you. If you have an idea for a webcast or would like to, maybe you'd like to see specific content developed for a future webcast, there's a URL for you. And of course, today's webcast was presented using Microsoft Office Live Meeting, and you can go here to get a free 14-day trial. And when you fill out the webcast evaluation for today's event, you're automatically entered to win this 40 gigabyte Creative Zen Ultra MP3 player. Pretty cool. And here is the web survey. Please follow the links provided in your interface and take a few moments to complete today's evaluation. Again, your comments are very valuable. And it looks like we have some questions in the queue, so I will hand the floor back to Ami to look into those questions that have come in.
Jeff, I'm having some trouble seeing those questions.
Okay. Can you open?
Oh, there we go. Okay. Yes, the URL I mentioned at the beginning of the thing and also at the end was windowscommunication.net. It's a partner to our windowsworkflow.net site. Someone had a question about the previous webcast. I'm not quite sure which one you're asking about. The one listed on the windowscommunication.net site is a link to the Faucet Technical Publications site. You can find that as well on the windowscommunication.net site. Another question was about the release of WCF. WCF is still under development. We will ship as a part of Windows Vista. So Windows Vista is set to ship inside of 2006. Unfortunately, I don't actually have a better date for you because the machinations of shipping something as hugely complex as Vista is pretty difficult to think about. WCF ships as a part of WinFX, and WinFX is Windows Workflow Foundation, Windows Presentation Foundation, which is previously known as Avalon, and Windows Communication Foundation, which used to be known as Indigo. WinFX will ship for Vista, inside Vista. It will also ship down level for Windows Server 2003 and Windows XP. We've released a bunch of community technology previews, and in fact, just a few weeks ago, we released a Go Live license for our January WCF Go Live release. That means that you can actually use WCF bits in production today. You can deploy on them. What I was using today is our January CTP, which is the most recent CTP. Are the contents within the square brackets? Yes. The attributes with which I was decorating the code today are actually part of the file. They are not merely comments. Those attributes are the things that are read to expose the methods and classes as operations and services on the wire. So yes, the code files are exactly as I showed them today. Is there no interop between WCF and .NET remoting? That is an interesting and difficult question. We think about .NET remoting as a fundamentally different programming paradigm. .NET remoting is all about tightly coupled services, tightly coupled relationships between a service and a client. And what that means is that you share a lot of objects, you share type. WCF is about more or less the opposite of that. It's about loosely coupled autonomous services in which you never share type. We do have more resources about this on the web. But what we are thinking is that WCF is the big bet that Microsoft is making. And it's a lot more difficult to get there from .NET remoting. So our advice is that if you're doing something that requires .NET remoting, then that's probably the best bet for you in the short term. In the long term, we highly recommend you start building new investments in WCF. There is some interoperability between them, but it might be easiest depending on what sort of optimizations you've made. If you've done a lot of custom syncs, it might be easier to go straight to upgrade there. Is WCF deployed with the .NET Framework 2.0? WCF will be deployed as part of WinFX, and WinFX is actually a superset of the .NET Framework 2.0. So we will require the .NET Framework 2.0 in order to run all the WinFX components. Can I give you some white papers for WCF? Everything that I suggest you check out our MSDN Developer Center, which is msdn.microsoft.com/webservices, and also the windowscommunication.net site that I've been talking about for a little bit. All of our links are over there. Are there chances that RTM introduces breaking changes for applications developed using the Beta 2 Go Live license? So just to clarify, the Go Live license out right now is not actually a Beta 2 license. We haven't released anything formally called Beta 2. The product is still under development, so of course things will change. It is a pretty stable product, and we are very close to what we intend to release. Most of our changes will be made for performance and stress reasons. That's what we're focusing on. But of course, the product is not yet completed, and so some things will certainly change before RTM. Can I clarify that all we need is the WinFX January CTP and Visual Studio 2005 to build what I built today on Windows XP Pro? Yes. If you go to our windowscommunication.net site on the bottom, I'm sorry to be pushing this site so much, but I spent a lot of my Christmas vacation working on it, so I'm very proud of it. If you go to the bottom of the home page, there's a pane called Getting Started. And in that, I actually lead you through writing almost exactly what I wrote today. And all you need to do that is to download Visual Studio 2005, the WinFX January CTP, and the Windows SDK, because that'll give you those tools I was using today. Can I leverage this from Windows CE, Windows Mobile environment? Yes, we don't actually have a specific version of WCF for the compact framework right now, but what we do recommend is that you use ASMX on the client side, ASP.NET Web Services on the client side to connect to, for instance, an Indigo server. Can I talk about the performance of WCF? We can't release formal performance data right now because as the product is changing, performance is of course going to change. And we don't want to be held to anything we say about performance in terms of specific numbers. What I can tell you is that WCF in our stress lab performs much better than even we had expected. So we're seeing performance equivalent to, say, enterprise services or .NET remoting on mainline scenarios, which surprises even us. We will be able to release formal performance numbers and case studies when we get closer to launch. Let's see, have I missed any questions? I have a question that says, how is WCF different from WS? And I'm wondering whether that just means web services. WCF is a good platform on which you can build web services. It kind of takes it to a new level of productivity and ease of use. So the idea of WCF is that things that were very difficult to do using typical web services, for instance, running a web services in an enterprise environment requires things like security and reliable messaging and transaction support, things that you used to need to roll your own version of. Instead of doing that, using WCF, you can invoke standard security support, standard reliability support, standard transaction support. So for one thing, you skip having to roll your own version of all those, which is immensely productive. But you also get, by default, interoperable features that coordinate with all of the other applications built on platforms that comply with the WS Star standard specs. Our organization is concerned about moving large volumes of data via services. Will WCF and MTOM over TCP be a good approach to evaluate? Absolutely. If I'm developing a new .NET web application that uses web services, should I use WCF now or wait until it is released with Vista? That's an excellent question. I think that it is really worthwhile to start investing in WCF now. But of course, that also depends on your business environment. It depends on your comfort level with working on something that isn't formally released and formally supported. It depends on the size of your application. Our general recommendation is that you will want to build new things in WCF because this is the Microsoft wave of the future. This actually subsumes all of the distributed technologies inside the .NET framework. But of course, we recognize that, first of all, you're not going to be able to transition immediately to using a new stack. Although, since the same group designed WCF as designed COM+ and MSMQ and .NET Remoting, we have tried to make it a logical next version. So if you're familiar with one of today's distributed systems technologies, using WCF should be pretty intuitive for you. So we've tried to minimize any cost associated with upgrade. But we recognize that it's difficult to use something that is not yet released inside some enterprise scenarios. Can you consume a WCF service from a client just like any other web service using Add Web Service? We are working on integration with Visual Studio 2005 as we speak. We do have templates inside Visual Studio 2005 when you download the Visual Studio extensions for WinFX. So if you download the little support pack that's also included with any of the installation documents, will tell you how to get there. If you download that, you get all of the integration stuff. So you get some templates, so you can use Add Web Service. You get that configuration file in IntelliSense, so IntelliSense and XML. You get all sorts of cool Visual Studio features that you can use for WCF, including that one. What are the requirements on the client side to run WCF? You need to be using Windows XP or Windows Server 2003. You need to have WinFX installed. Let's see, did I miss any questions? If I did, please call my attention to them. All right, I think that might be it. Thank you all for joining me this morning. I hope you enjoyed the program. If you did, I would love it if you filled out an evaluation. If you didn't, I guess Jeff is still on the call, so I can't make vague threats. Enjoy your days, and I hope to see you at the next webcast.
Okay, well, I would like to extend a special thank you to Ami for presenting today. Great job. And thanks to everyone for attending this webcast. Ladies and gentlemen, that concludes today's MSDN webcast. Thanks again for joining us. You may now disconnect from the audio portion of this conference.